So why should you care about priorities of the contract filtering rules? If everything is a allow list, if you just enter configurations to allow traffic for specific ports and everything else is denied, priorities don't have any meaning. But from ACI 3.2, you have the option to configure rules to deny traffic. And so you need to care about which rule wins, because you could have traffic that is hitting multiple rules, and one rule could say the traffic is denied, another rule may say the traffic is permitted. Or you could even have a service graph with a redirect action. And so reality is you can have multiple different results for the same traffic that is filtered by ACI. So that's why you need to care about contract priorities. So which are the filtering rules? From a very high level, the following high-level rules apply, and then they will ease in the details. So more specific EPG to EPG rules will over less specific being rules that involve vzAny. Deny wins over permit or redirect. More specific filter configurations win over less specific filter configurations. For instance, a rule that specifies a protocol and layer 4 port is more specific than a rule that doesn't specify a protocol or it doesn't specify layer 4 ports. Redirect wins over permit. These are the high-level rules, and it's easy to simplify and to remember, but then make sure you understand the details as these slides now are describing, because the day will ease in the details. So let's start from a most common configuration just to remove any mystery about the rules. The most common situation that you can find in the policy cam is the implicit deny, which is always configured, and it has a priority of 21. And the permit rules of the contracts that you configure that normally have a priority of 7. A lower number wins over a higher number. So lower number means higher priority, hence it wins. So normally your EPG to EPG contracts win over the implicit deny. So let's talk about the filtering rule number 1. I categorize rules into 4 different types of rules. Let's start from filtering rule number 1. The filtering rule number 1 is that a more specific EPG wins over any combination of EPG and vzAny, okay? And this is part of what's called the zoning rule priority. So EPG to EPG rules have a priority of 7 or 9, and we'll see that in a few slides, what is the 9 about. Most likely, it's what you're using is going to be priority 7. EPG to vzAny, normally it's priority 13, and notice that EPG to vzAny has a higher priority of the vzAny to EPG rule. So rule with a fully specified source EPG has priority of a rule with a fully specified destination EPG. And finally, vzAny to vzAny has priority 17, which is higher than the implicit deny that has priority 21. So a more specific EPG that you specify in the contract configuration wins over a configuration that includes vzAny. So notice that if you have a rule that says EPG1 to vzAny do something, and then vzAny to EPG2 do something else, and you have traffic destined from EPG1 to EPG2, the first rule, the EPG1 to vzAny rule, is the one that gets applied. Okay, so again, EPG to EPG wins over the other combinations, and the lowest, highest priority being EPG to EPG, the lowest being vzAny to vzAny, and in between you have the rules of EPG to vzAny and vzAny to EPG. Now, a very important point is that no matter what are the layer 4 filters or layer 4 ports, or in general the filters defined within the contracts for the EPG to EPG, vzAny to vzAny, and so on, the priority is the same. What that means is that even if you have let's say you have a vzAny to vzAny rule that has a matching for, let's say, port 80, and then you have an EPG to EPG rule that has a match for any layer 4 ports, it doesn't change the priority. The EPG to EPG is priority 7 and wins over vzAny to vzAny, no matter the specificity of the layer 4 ports or protocol matching that you define within that contract, okay? So this is rule number 1 because of that reason. Is the first criteria where you need to filter traffic, which layer 4 rules or which other filtering rules you're going to look up depends on which one of the EPG to EPG or vzAny to vzAny or vzAny to EPG rule is matched, okay? Just to give you an example, if you have here an EPG1 to EPG2 contract, which specifies any layer 4 ports with action permit, and then you have vzAny to vzAny contract, which is more specific. It matches port 50, and it has a redirect. The traffic from EPG1 to EPG2 for UDP with destination port 50 is allowed, is not redirected, okay? So what matters is the fact that it's matching the rule with priority 7, even if port 50 could let you think that the vzAny to vzAny would be matched, but it's not the case. Filtering rule number 2. More specific filters also have an implication on which zoning rule priority the contract configuration gets. So this at a first level seems to contradict what I just said about the filtering rules. This is about ether type, okay? So you remember that for EPG to EPG, I was telling you that the contract could have priority 7 or priority 9, and then remember that for the vzAny to vzAny, I was telling you the priority could be 17, but it could also be 21, okay? The difference is that if you have an EPG to EPG with a fully specified ether type, it's get priority of 7. If instead the ether type is any, is the catch-all, the EPG to EPG rule becomes priority 9. And the same is true for the other combination of EPG and vzAny. If you have an EPG to vzAny rule, it has priority 13, but if the type is any, okay, and not a fully specified ether type, then the priority becomes 15. So that's why each of one of those zoning rules has two different possible priorities. It depends on the ether type. Okay, so again, ether type IPv4, everything else unspecified, the priority is 7. If also the ether type is unspecified, the priority of the PG to PG rule becomes priority 9. So now, which rule is used if there are multiple filters within the same EPG to EPG contract or EPG to vzAny contract, and multiple filters are matching the same traffic? So in this case, if there is a deny plus log action for one of the rules, that action wins over deny actions rules, whichever they are, which in turn win over redirect or permit rules. So this brings us to rule number 3, which is what we just described. So deny in general wins over redirect or permit, and this is within the same zoning rule priority. Okay, so take an EPG to PG contract, priority 7. If you have traffic that is matching some rules with deny, some rule with permit, then deny wins. Okay, and this is regardless of which rule has a more specific filter. So let's take an example. Let's say that the policy CAM configuration consists of a rule that says permit traffic of protocol UDP with a destination port 50. Okay, and then you have a deny rule that says deny IPv4 traffic, any protocol, any port, and so on. Now, if you send traffic with destination port 50, the traffic is denied and not permitted. This is the key point, okay? So traffic with destination port 50 hits the deny rule and not the permit rule. And that's because the deny rule has higher priority over permit rules by default, okay? It can be changed, but by default it has priority over the permit rules. And we're gonna talk about how to change that later. Okay, so let's talk about the filtering rule number 4, and which is the last one. So within the same zoning rule priority, between permit and the service graph redirect action, rules with more specific protocol or layer 4 ports win over less specific rules. So if you have a rule with a specific protocol, it wins over a rule without any protocol. If you have a rule with layer 4 destination ports, it wins over a rule without layer 4 destination ports. And for the case of rules with source port any destination port specified or vice versa, the specific priority is that the destination port, destination layer 4 ports, wins has more priority than a rule with the source port defined and not the destination port. Okay. Now, if the filters are identical between the redirect and permit, the rule that gets programmed is the redirect rule. Now, there's also a possibility that you have rules that have the same level of specificity and they are overlapping. An example is source port any to a range as a destination port that includes, for instance, port 80, and then you have another rule with source port any and destination 80. This cannot be resolved by ACI. So these rules get programmed, but the result, it's random. Okay, so you are not supposed to use these kind of rules. So this is a table that summarizes different priorities. So highest priority goes to the rules that have both layer 4 ports specified, and then all the other combination, and the lower priority rule is the one that where protocol and layer 4 ports are not specified. Examples here, let's take a configuration where the protocol is specified, it's UDP, and the action is permit, and then you have another rule that has any, and the redirect. The rule that wins is the UDP rule. So permit traffic is winning. Let's now take an example of a rule that says source layer 4 port any and destination port 50, and it is permit, and another rule that says source layer 4 port 63 and destination layer 4 port any, the action is redirect. If you have traffic that has source port 63 and destination port 50, the action that ACI takes is permit. Why? Because the destination layer 4 port wins over the source layer 4 port. This is the opposite example where the redirect is applied to the rule where the destination port is 50 and permit is applied to the rules where the source port is 63. So traffic that has carries source port 63 and destination port 50 in this case is redirected. This is the example of what you shouldn't do. You shouldn't specify overlapping rules like this one where both destination ports are overlapping. And in this case, ACI cannot resolve this. So this result here depends on what has been programmed in the hardware, in which order, and so it's not deterministic. Okay, so now you know the 4 rules. That's it. These rules are very simple, and we've seen them. How about being able to choose whether the deny is applied or not? Okay, so we were saying the deny wins over the permit or the redirect within the same zoning rule priority, and regardless of the specificity of protocol and layer 4 ports. When you configure deny, the default value, the default is called default. So by default, you get the default level of priority, which is the same level of the other rules of that zoning rule priority. So if you have an EPG to EPG contract and you have a deny rule in that contract, among other rules, it gets a priority of 7 because it's the same priority as the other rules. But you can also change that. You can also give that rule a lower priority. For instance, you can give it the medium priority, which is the equivalent of a zoning rule from, say, source EPG to any. Or you can even go even lower priority, which is the priority of any to any rules with iter specified. Or you can even give it the highest priority, which is priority 7. So this gives you more control into which order the deny rule that you entered is applied. Okay, so let's take some examples. So imagine that you have a configuration that says permit UDP traffic with destination port 50, and then deny any protocol, any layer 4 ports, and so on. So if you send traffic with destination port 50, this traffic is dropped. Why? Because as we explained before, the deny rule wins. But what if I want to create a catch-all deny within my contract? Okay. In this case, what you can do, you can change the priority of the deny and give it either the medium priority or the lowest priority. And in this case, when you send traffic with destination port 50, the traffic is permitted because it hits the first rule, and the first rule has priority 7 versus the deny rule has a priority of 17. Let's take a look at a case study. So the requirement here is to allow all EPG traffic by default because maybe we are in a migration phase, so we want to allow traffic that was previously allowed. And we want to add more security rules to create more specific filtering rules between EPGs and introduce security step by step. How can you do that? Well, one way to do it is to use a vzAny configuration with a permit IP any, so that all traffic between EPGs is allowed. Okay, and this would be the programming of the policy cam. So you'd see here the vzAny rule with priority 17, which is higher than the implicit deny. So traffic is now allowed. Now you can add more specific contracts. Okay, and for instance, you may add a contract to permit traffic for UDP at destination port 50, and this would allow the traffic. But then you need to do something else because you also have the implicit permit now that you mean the vzAny permit. You want between these two EPGs to apply more specific filtering. So what you need to add is a deny rule within the contract, within the EPG1 to EPG2 contract, so that traffic that doesn't hit the permit rules is denied. Now, if you just put any deny with the default level, this will also drop traffic destined to port 50. So what you need to do is to enter the deny, but to use a lower priority. You need to use, for instance, the medium priority so that the permit rules are taking priority and the deny rule becomes the implicit deny only for that EPG1 to EPG2 contract and not for the entire configuration of that VRF.